This RC boat isn't powered by an electric battery. It's powered by the force of the atmosphere. I made a similar boat over a year and a half ago now. If you haven't seen that, click here. It essentially worked by plugging the end of a syringe and winding back the piston inside the syringe using a gear mechanism, thus creating a vacuum. The difference in pressure between the inside of the syringe and the atmosphere results in an imbalance of forces on the piston. So the atmospheric pressure forces the piston back into the syringe once you release the mechanism. This energy is then harnessed to spin a small propeller and push along a boat. You may be thinking to yourself, atmospheric pressure isn't that high. How much force could it actually deliver? Imagine you laid flat on a table and a vacuum pump sucked you to the table. We can quickly work out how much force you would need to overcome. Force equals pressure times area. We know that atmospheric pressure is 1 atmosphere, so we just need a rough approximation of the surface area of the human body. So when we do the calculation, that gives us a force of roughly 86,126 newtons. Here on Earth, that would feel like 8,800 kilos, or the equivalent of roughly 6 hippos, or just one of your mother. Using these same principles, we can roughly work out how much force is required to pull back a piston of a certain diameter. This syringe has an internal diameter of roughly 4 centimeters, and therefore will require roughly 12.3 kilos of force in order to pull it back. I wanted to see how close this calculated value was to the actual value I'll see with the syringe, so I carried out a simple test using a luggage scale. And just to be on the safe side, I had Nala supervise.
Safety is number one priority.
So it comes out at just over 14 kilos, which isn't far off the calculated value. I think the main reason for the difference is the increased friction with the rubber seal on the syringe. My first boat was powered by one of these syringes, which, in principle, did work. I think it's fair to say there were a few design flaws, and thankfully, a few of you were kind enough to point them out in the comments of the previous video. So, in this video, I'm hoping to address most of these concerns. The shape of the boat is not ideal. With this big, flat bottom, it's basically a barge, not a boat. So I've completely redesigned the hull so that it now actually looks like a boat. Half of the propeller was out of the water, so the boat just spun in a circle. I've since learned this is called prop walk. This basically means the rotation of the propeller creates a paddle wheel effect, which causes the boat to turn to one side. The redesign of the boat hull was aimed to solve this problem, and I put the propeller shaft as low down in the hull as possible to make sure that it stays fully submerged in the water. There was one other thing that a few people mentioned. I'm just trying to remind myself of what it was.
Install a rudder, put a rudder on, put a rudder on, put a rudder on it, put a rudder on it.
So I'm going to put a rudder on it so that I can control the direction in which the boat is going. Now, not having a rudder was an intentional decision, as I just wanted to make a simple boat without the complexities of having any electronics on it. And honestly, in my ignorance, I wasn't expecting it to basically be a merry-go-round. I've made some other improvements too. At least, I think they are. I'm now using a planetary gearbox instead of whatever the hell you want to call this. The benefit of using this planetary gearbox system is that I've designed it in a modular fashion so that I can add or remove segments to change the gear ratio depending on if I want more power or more range. This mechanism is going to potentially have more torque than the last one, so I'm hoping the extra tough contact area is going to reduce the chance of something breaking. It probably won't, but we'll see.
You're goddamn right.
In simple terms, a planetary gearbox is made up of a sun gear, planet gears, and a ring gear. The planet gears revolve around the central sun gear, with each of the planet gears connected by a carrier, and the outer ring gear is fixed in place. The mass behind determining the gear ratio is slightly more complex than for standard spur gears, but basically you can just use this formula. In this gearbox, every time the planetary gear carrier rotates 1 time, the sun gear will rotate 3 times, giving it a gear ratio of 1:3. By connecting these together in series, I can get quite the large gear ratio pretty quickly, which means that for a small movement of the piston, I can get a lot of rotation at the propeller, hopefully giving the boat a good range. Though I can see a potential issue from the increased friction due to the greater gear contact area. There also may be an issue with the center of mass being too high on the boat, as due to the size of the planetary gearbox, I had to mount it at the top. Now, my favourite part of the process, spending an entire week printing and troubleshooting issues with my design. I printed off the planetary gear set first, just to see if it all actually worked as intended. This took quite a while to do, because some of the parts are really small and fiddly, so it's quite hard to get together, but eventually I got all 4 modules together. And it didn't work. So So then I took one of the modules off and tried again, and this time it seemed to work fine and felt pretty smooth. So I thought I would just try and make it work with 3 modules, as I could already see friction was becoming an issue, and I haven't even added on the bevel gear or the belt yet. To make the gear fit with just 3 modules, I printed an extra long shaft, which would extend to where the belt was supposed to connect. The next part to print was the gear and syringe reel support. This part needs to be able to withstand the force being exerted on the piston as it's being pushed down the syringe, and it also needs to connect the motion of the 2 syringes together into a single output. This piece was a nightmare to print. The first time I snapped it pulling off the bed, and the next time it caused a clog in the printer nozzle and the Bowden tube. I then replaced the nozzle and the Bowden tube, and it failed again. So I don't know whether it was something wrong with the model or the filament, but regardless, I was fed up with this red PETG filament. So I bought some yellow filament instead, and this worked beautifully the first time. The next thing to print is the boat hull, and this is probably the biggest thing I've had to print on my 3D printer so far. As I only have a measly Ender 3, I had to split the model into 3 parts. I printed the largest middle piece first, and honestly, the quality of the print was pretty poor. There were some pretty large gaps in the outer shell, there was lots of stringing, there was zits, blobs. I had just changed to a new filament and increased the nozzle size, and didn't do any calibration test. So I only really have myself to blame. But as I'd pretty much used up 1/3 of the filament with this one print, I couldn't bring myself to throw it away. The dimensions were actually pretty good, and all the pieces fitted as I'd hoped. Shit. Except for this part, which required some mild destruction as I had modelled it wrong. The hardest part to fit in was the propeller, because it was a friction fit, which needed to be very tight to prevent any water from coming in. To make sure it fit tightly, I slightly undersized the hole and gradually sanded away at the inside until I felt like it would fit snugly. So then I just had to carefully slide in the propeller and just make sure I don't damage anything. Yeah, buddy. Then I printed the front and rear sections, and they were just as bad as the middle section. But anyway, I hoped the post-processing would fix these issues, so I just carried on. Before gluing all the pieces together, I tested to see if the mini servo would fit into the slot that's printed in the hull. And also that the RC controller, servo and receiver were all working correctly. It all seemed to work fine, so then I just had to glue all 3 sections of the hull together using the cheapest epoxy resin glue I could find on Amazon. To waterproof the hull, I used a sealant spray, and I applied multiple coats due to the complete lack of confidence I had in the watertightness of the hull. Once that was done, it was time to start putting together all the moving parts. The motion of the planetary gears is transferred as low down as possible into the hull via a belt drive, where it attaches to some brass tubing and then attaches to the propeller. The problem with this is that the connector for the belt drive and for the propeller are 2 different diameters, so I can't just use a single brass tube as it doesn't fit. So to deal with this, I utilised my horrendous soldering skills to solder together 2 brass tubes of different diameter. After cooling the burn on my thumb for about half an hour, I went back and finished the assembly. Again, being careful not to damage the delicate propeller when fitting it to the hull. The brass tube connects to the belt pulley and the propeller by a set screw, and once I'd secured both ends, I could quite freely spin the belt drive and the propeller mechanism. Though it was slightly off centre due to my shit soldering, this was compensated for by the joint on the propeller, so I wasn't too concerned about this. Next was the rudder assembly, which looked great in CAD, but once I tried to fit it to the boat, I quickly realised this wasn't actually going to work. So I immediately destroyed the evidence. Then I just slightly redesigned the rudder assembly so that I could actually install it on the boat. And then all that was left to do was to connect up the servo, some power, and see if it all worked.
Whoa, we have success, baby! Let's go!
I already had one piston from the previous boat build, so I reused that and printed off another one for the other syringe. Then was possibly one of the most painful steps in this entire build process, which is trying to thread this fishing line through this 2mm hole while it's attached to the boat. Now you're probably thinking, why didn't you just take out this part so that you had more room to work with when you were trying to thread the fishing reel through the 2mm hole? And that's a fantastic question I don't have an answer to. The syringes then slot into the gaps in the hull, and the ring gear mount is placed on top of them and secured at either end with 2 screws. The belt then has to be cut to size, so I just eyeball the measurement and use this technique I found on YouTube of cutting up some cloth and applying it to the back of the belt with copious amounts of superglue to join the 2 halves together. As you can see, this worked brilliantly. The final piece of the puzzle was to install the bevel gears. I then noticed I would need to provide some additional support via another bearing above the large bevel gear as it was very wobbly. So I designed this bearing mount and connected it to the hull using these 2 slots, which I built into the model in anticipation that I would need to add things later because it probably wouldn't work. And with that, the boat was finished, so I showed it to the boss, who approved of it with a sniff and a slap. So I filled the bath and started to wind up the mechanism, and almost immediately, it snapped. This is why you should test things along the way, and not when you've finished. As I had already waterproofed the boat, I thought I may as well see if it even floats before I pump even more time into this design. Luckily, it did float, so then I just needed to deal with the design issues. The part snapped because it was printed in a vertical orientation, and due to the way in which force is being applied to this part, the strength is totally reliant on the bond strength between the different layers. So to easily overcome this issue, I can just print the part in a horizontal orientation. Another problem is the significant amount of friction in the ring gear system. Now my printer is an Ender 3, which is an FDM printer, which basically deposits layer after layer of melted plastic on top of each other to build up a part. Another type of printer is known as SLA, or stereolithography. These printers use a photosensitive liquid resin and uses UV light to cure the resin layer by layer to create an object. One of the benefits of a resin printer is that it can have a much smoother surface and higher dimensional accuracy compared to an FDM printer, so I thought it would benefit the gear train to help reduce friction. However, there's a slight problem in that I don't currently have a resin printer, or a place to store one in my house without stinking out my entire house with resin fumes. So that's where this video sponsor, PCBWay, was able to help. I uploaded the ring gear components to PCBWay and got them printed using an SLA printer. Just a few days later, they arrived at my door, and after removing them from their protective packaging, I immediately noticed how much smoother these parts feel compared to the FDM printed parts I'm used to. There's also a clear improvement in the amount of friction in the gears too, as I was able to run this one with all 4 modules connected together, which I couldn't do with the gears that I'd printed. It's also pretty cool that the prints are slightly transparent, so you can see the individual gears inside moving. Though it does work with 4 gears in series, to keep friction to a minimum, I still decided to stick with 3 modules in series as a first attempt, just to try and get it to work. So I've also had to go through numerous iterations on the front here. What was once just a simple pulley system has now had to be turned into a gear and pulley system. The reason for this change is that the space between here and here does not fit any standard belt sizes. And where I've shown previously that I've glued the belt together, this really does not work in this kind of application. Any sort of bend on that joint and it just wants to snap. So for a pulley system that's going around like this, it is completely useless. So we can see with this system now that we actually have very little friction here. And I can actually spin it from the main cog, which is something I wasn't able to do before. Here's the moment of truth. Will it survive the wind-up? Shit. Something has broke somewhere. It's no longer spinning the front cog. Found the problem. You see that? That was connected to this. It's not supposed to do that. As I was taking apart the gear assembly to reinstall another bevel gear, I tried winding back the mechanism on its own and noticed that one of the pistons was moving up the syringe slower than the other one. So then I tried both pistons in the same syringe to see if it was an issue with the 3D printed piston. But there actually seemed to be something wrong with the syringe itself, as both of the 3D printed pistons were getting stuck at the same place in the syringe. But in the other syringe, both of the pistons would move freely up and down. Luckily I had another syringe, so I just swapped out the broken one and it immediately worked much better, with both pistons moving at the same rate. So then I just had to put the gear train and bevel gears back on and try again. I can actually move the bevel gear relatively easily, so I think it has a pretty good chance of working this time. About a quarter of the way up. I'm gonna stop here. And then, absolutely nothing. Come on! And that is So I think the issue had something to do with the fact that the vacuum space here was linked. Basically all I've done here is cut these bits of tubing shorter and isolated each syringe. Setting it up like this actually makes it easier to recharge it as well, so I don't know why I didn't do this in the first place. The next test I did outside because Nala wanted to see the progress I'd made. After winding up the mechanism, there was nothing that snapped, so that was good. When I let go, nothing happened. Again. You can't really see very well from this angle, but instead of the larger bevel gear spinning the smaller gear, it was just pushing it off to the side, so it was getting stuck. I thought maybe they were installed too close together, so I just pulled it back slightly, and then this happened.
Balls.
I put it together again, and actually got some motion out of it, which excited Nala. But it wasn't enough. So then I thought, maybe it's an issue with the bevel gears, because I did have to sand them slightly, and I also designed them manually, so chances are there was probably something wrong with my design. I then thought back to my previous boat, which had bevel gears which seemed to work perfectly fine. So I made some slight modifications to the models and then added them to this boat.
If I could brace it, maybe, and stop it moving side to side, maybe it would be more inclined to spin.
This is the easiest I've had it move so far. Looking good.
No! God! No!
That's never a good sign. Let's just keep going until something breaks. I carried on winding it up despite the clicking to figure out what was going on. That doesn't sound good. Doesn't sound good. If you look closely, you can see that the bracket supporting the bevel gear is being pushed backwards, which is causing the gears to skip. In addition to this, the whole gear train was still being pushed off to the side instead of rotating. To try and fix this, I printed a whole new gear mount to try and hold it in place better. However, I forgot about these little screw slots which were stopping me moving the gears in and out, so I had to cut them off, which was actually pretty violent. Despite this change, the gears were still skipping, and honestly, at this point, I was pretty fed up with this project, so was ready to give up and call this a failure. But a few weeks later, I had one more idea on how I could potentially save this project. Looking back at the footage, I noticed the ring gear was being pushed upwards, and I realised this was because I was lazy and didn't put the screw in here, as I assumed the mount was held in place with the other screws. Locking this down would stop the mount moving upwards and, hopefully, stop the gear skipping. Another issue was that the very first planetary gear, the connection to the bevel gear was very shallow, and I think this was allowing it to shift around and not stay aligned. Another problem was with the actual bevel gears themselves. They were awful. I think they only worked on the original boat because there was very little torque being delivered through them as they were right at the end of the gear train. On this boat, the bevel gears are experiencing the maximum torque that this boat can deliver, so the alignment has to be much better. In the end, I just bought some machine bevel gears because I was sick of trying to design and print mediocre bevel gears from scratch, which just weren't working in this design. I didn't design the bearing mount with this bevel gear in mind, but by absolute blind luck, the bearing fits perfectly within the cutout in the center of the bevel gear.
It's beautiful!
It wasn't all perfect, as I had to make some minor modifications to the underside of the bearing mount, as the bevel gear was sticking into the underside of it and wouldn't rotate freely. After reinstalling the bearing mount, I tested out by hand, and this was definitely the smoothest it has been so far. So once again, with my hope restored, I wound it up with my drill, let it go, and was once again left disappointed by this piece of shit. I noticed again that the bearing mount was being pushed backwards, so I added these supports which held the bearing mount in place by bracing it against the gear train. After trying to wind up the mechanism again, there was a lot of creaking and cracking, and then I noticed this. The bevel gear had been bent sideways by the force, and when I took it apart, I found this part had been completely twisted by the force, but somehow had not snapped. So I made some adjustments to the model to increase the strength. I then found the reason for the clicking, which was the bevel gear picking up the bearing as it was rotating. Not such a perfect fit after all. So I printed this add-on piece which moved the bearing higher up and stopped it from contacting the bevel gear. And this time, it actually worked pretty well when I wound it up, and I thought it was ready for a bath test again. Now this test was not very confidence inspiring at all. One, because it was almost sinking, and two, because it barely moved because of how heavy it was. But anyway, I took it to a nearby pond for a test because why not? The test was an absolute disaster. I was pretty disappointed, but at the same time, it was pretty funny how pathetic it looked.
I am under the water. Please help me.
I then gave up on trying to make this boat work for like a week before I thought of one or two ideas on how I could potentially make it work. I redesigned the hull lid so that the battery would sit on top and be held in the middle so that it wouldn't tilt to either side. For the issue of the machine bevel gears scraping along the shaft, I then designed these small indentations in the shaft so that the set screw could sit inside them. After looking back at the footage with the bearing placed higher, I could see that it was skipping again because it was being pushed backwards as it was not connected solidly to the mount. I tried to fix this by printing it as one piece instead of attaching it to the top. Oh no! But once again, after winding it up to a certain point, it was just skipping gears. So I never actually took this out to test because it was completely pointless. I think this is a pretty good time to call it quits for this boat, as it clearly needs a complete rework, and adding small pieces here and there to try and fix multiple problems just isn't going to work. If you have any ideas on how to improve this design, please let me know in the comments. I'm in dire need of help. I'd just like to thank PCBWay once again for supporting this video by providing the resin printed planter gear set. I was really impressed with the quality of the prints and the quick turnaround on the parts. As well as the 3D printing services, PCBWay offers several other services which can help support your project, such as CNC milling, sheet metal fabrication, and custom PCBs. So make sure to check them out for your next project. Until next time, thanks for watching.